Hello everyone, welcome to yet another video on electromagnetic fields. So in today's video, we are going to discuss about Gauss Law and its importance, Ideate based approach. So we have our mentor students, Sai Prasad, Pradeep, Nikhil, Ashwin and Ashwita, who are going to discuss about why we need Gauss Law, what is important, what is the need for Gauss Law in electromagnetic field analysis. So let's get into the video.
I'll be explaining the empathy part. There are many students, including us, finding it difficult in how the field lines works. So, when there is many charges together, it becomes confusing to calculate the total electric field. Using Coulomb's law every time becomes long and complex scheme. So, here the student finds it difficult to learn. This is why we need a simpler and easier method to find the electric field. So this moves us to the Gauss law.
So because by using Coulomb's law, we can find the electric field between two charges. So if we want to get the electric field of a total volume, we have to go for superposition principle. So in order to overcome this problem, we move on to Gauss law. So let's now get defined with the problem statement.
Here comes the defined part where the problem we need to solve in electrostatic manner. When the charge is placed in free space, all the charges conduct an electric field between them. Though Coulomb's law is complicated over charge distribution, we need to integrate them. So we concluding with the Gauss law, which relates the charges to the total electrons.
The charges of electric flux
Bigger volume, we can use Gauss law, where which we can easily find the electric field. Next.
Hello, I am going to say about a prototype. For applying Gauss law, per sphere, the electric field spreads equally in all directions. Infinite sheets of charge, it radiates outward like spokes, and in a uniform charge wire, material electrics, non-conductive stand, spherical conductor, non-conductive stand, spherical conductor, high voltage power supply to connect the sphere, measuring tape, and
so he have explained about how we can find Gauss law through an experimental setup. So next we come to the testing part.
Finally, while testing, we get Gauss law by comparing its result with the Coulomb's law. In most of the cases, we get the same answers. So it proves that Gauss law is more reliable, easier and powerful. Conclusion: Gauss law not only gives calculation, it also help us to understand about some basic knowledge about electrical field. And it's fundamentally used. Fundamental tools are used in physics for reduce complexity and improve clarity.
So at a summary, I would like to conclude that Coulomb's law is the basic law or foundation law for finding the force between two charges and the electric field that exists between the charges. But with that formula or with that law, we can only calculate the electric field for a confined or a smaller area. If you want to calculate the electric field for a larger area, Coulomb's law is not that much faster. So Gauss law is a good substitute for Coulomb's law because it is the fastest method in which you can easily calculate electric field for a larger volume or any kind of surface like symmetrical surface and unsymmetrical surface. So Gauss law finds applications in all areas wherever we want to find Gauss law. So wherever we want to find electric field, we can apply Gauss law because as rightly said by the students, both Gauss law and Coulomb's law yield the same results. So wherever Coulomb's law is not applicable, we can use Gauss law since it provides faster and reliable results. So thank you for watching this video. So in this video we have discussed about what is Gauss law, why we need a Gauss law through the defined part, and finally we end up with the testing part. So thanks for listening. We'll meet you in the next video. Thank you.